Imagine a wildfire so incredibly powerful, it doesn't just burn everything in its path, it actually starts creating its own weather. We're not talking about just a little bit of smoke drifting around. We're talking about massive, towering storm clouds that can even spark their own lightning. It sounds like something out of a sci-fi movie, right? Well, it's very real, and scientists call these phenomena Pyrocumulonimbus clouds, or PyroCb for short. Think of a regular thunderstorm cloud, but supercharged and fueled by the immense energy of a raging fire. These are literally fire-breathing storms, and they're one of nature's most astonishing and terrifying displays. So how does a wildfire transform into a lightning-generating weather system? It all starts with extreme heat. Picture a vast forest fire, burning with such intensity that it sends a colossal plume of superheated air, smoke, and ash rocketing miles into the sky. We're talking about temperatures that can reach over 1,000 degrees Celsius at the fire front. This isn't just smoke lazily drifting, it's a powerful, violent updraft, like a giant atmospheric chimney. The hot air rises incredibly fast, pulling everything with it: ash, embers, tiny particles, and even water vapor evaporating from burned vegetation and moist ground. This convective column can climb at speeds of up to 100 kilometers per hour. As this superheated column rockets upwards, it punches through different layers of the atmosphere, often reaching heights where normal thunderstorm clouds form, sometimes even higher, well into the stratosphere. To give you an idea, a typical PyroCb plume can reach 10 to 15 kilometers, which is higher than where most commercial airplanes fly. Up in those extreme altitudes, the air is freezing cold, even if it started hot at the ground. All that water vapor and the tiny ash particles act like seeds. Water condenses around them, turning into ice crystals and supercooled water droplets, just like you'd find in a regular powerful thunderstorm cloud. It's the perfect recipe for a storm. But here's where the pyro part comes in and adds a surprising twist. The ash particles and embers from the fire add an extra punch to this cloud mixture. As these ice crystals, water droplets, and fire-generated ash particles collide within the rapidly rising column, they rub against each other intensely. This violent friction is the key. Think about rubbing a balloon on your hair. That's static electricity. Inside these PyroCb clouds, billions of these tiny collisions create a huge separation of electrical charges. Lighter, positively charged particles tend to move up, while heavier, negatively charged particles gather lower down in the cloud. It's a massive battery building up. When this electrical charge difference becomes too immense for the air to insulate, boom, nature balances the books with a massive spark, lightning. And this isn't just any lightning, it's lightning generated directly by the fire itself, often striking the ground far away from the original blaze, sometimes even more than 100 kilometers away. This is where it gets really scary and creates a terrifying feedback loop. Lightning strikes caused by a PyroCb can ignite entirely new fires, sometimes miles away from the main fire. These new blazes then add more fuel to the atmospheric chimney, potentially creating more PyroCbs and more lightning, fueling even more destruction. Beyond the lightning, these clouds have another shocking impact. Their incredible power can inject smoke and aerosols, tiny particles, directly into the stratosphere. This is a layer of the atmosphere that's usually very stable and clear, far above where normal weather systems occur. It's a huge disruption. When smoke reaches the stratosphere, it can stay there for months, even years, because there's very little rain or weather to wash it out. Carried by high-altitude winds, it travels around the globe, potentially affecting weather patterns, cloud formation, and even the global climate on a much larger scale. It's like a tiny climate-altering volcano. Scientists are observing more and more of these PyroCb events, especially with hotter, drier conditions fueling larger and more intense wildfires worldwide. It's a stark reminder of our changing climate and how extreme weather events are becoming more frequent and severe, creating new challenges for our planet. So how do we track these fire-breathing storms? Satellites are key. They can spot the distinctive plume shape, the incredibly high altitudes, and the temperature signatures, helping meteorologists warn firefighters and communities about the potential for extreme fire behavior and lightning strikes. Early detection is crucial. Researchers are also using specialized sensors, drone technology, and advanced atmospheric models to understand the exact physics of how these clouds form and generate lightning. Every bit of data helps us predict their behavior and impact better, which is vital for developing strategies to mitigate the damage. Pyrocumulonimbus clouds are a powerful, frightening example of how extreme weather and climate change are creating new, dangerous phenomena. They show us just how interconnected Earth systems truly are, where a fire on the ground can literally reach up and change the weather miles above, affecting the entire globe. Understanding these fire-generated storms isn't just fascinating science, it's crucial for protecting our communities, our ecosystems, and our natural world. The more we learn about these incredible yet destructive forces of nature, the better equipped we become to adapt and respond to a changing planet. What are your thoughts on these astonishing fire-generated storms? Did anything surprise you? Let us know in the comments below. And if you found this deep dive into nature's wild and complex side enlightening, hit that like button and subscribe for more amazing discoveries and insights into our incredible world.